Welcome everyone. I hope you can hear me. I haven't done live streaming in a while, so I hope I did set up everything correctly. Just in case, let me know. I'll try to monitor chat or whatnot. So yeah, today's topic is learning Dart. I have a specific need. I need to learn the Dart programming language as fast as I can so I can get up to speed with just, you know, being productive in code bases. And that's pretty much the goal. So yeah, let's move on to the regular thing. And let's literally search for Dart language. Let's see what we can find here. Dart programming language. There we go. So I'm actually gonna take in roughly everything from scratch as if I was the person for the first time introduced to the concept of Dart. Heard about it before. I believe I looked at it before. So, yeah, we'll see how that goes. Let me just quickly turn a few things off first, because I can see some things running here that weren't supposed to. We don't want issues. There we go. There we go. There we go. Beautiful. All right. Back to work. Okay, paint your UI to life with Dart's VM's instant hot reload. What? It's like it's trying to sell me something. An approachable, portable, and production language for high-quality apps on any platform. I won't be watching the videos. We'll just focus on text. So approachable. Develop with a consistent, concise, and strongly typed programming language that offers modern features like null safety and pattern matching. Okay, productive development. Make changes iteratively. Use hot reload to see the result instantly in your running app. Okay. And portable and fast on all platforms. Compile to ARM, x64, RISC-V, machine code for mobile, desktop, and backend. Or compile to JavaScript and WebAssembly for the web. That sounds good. Yeah. Okay. So, yeah, we have the approachable. Oh, we've got some examples. All right. I don't like that this background is white. Oh, it does bug me. Okay, mature and complete async await for user interfaces containing event-driven code paired with isolate-based concurrency. Wait, is it for user interfaces only? Or can I use it on backend? So fetch temperature, which is an async, and we just await a response. I guess final would be like a constant in JavaScript. So we await it and we do something with the result and bam. No big deal. Then we have write safe and concise code using features like sound null safety, collection if, and pattern matching. All right. So tab bar build. Build context. So collection if, pattern matching, and sound null safety. All those are supposed to be here, right? So we have some kind of build function that I presume returns tab bar. Takes in context that's of type build context. All right, so that there's nothing innovative here, right? And then we'll return. So we take a tab bar, so I guess we created here, and we define that the tabs are new tab here, new tab here, new tab there, and then if promo active, then we'll return a tab. Oh, so this is collection if. Oh, so basically this entire end Oh, that's actually fun. So this entire part of the return collection will be there or won't be there depending on this if, all right? So that's kind of fun. You don't have to fiddle with either adding it afterwards in a separate space, or in JavaScript, in theory, you could return undefined or whatnot. But this is nice and clean. I like that. A consistent programming language with an easy to learn familiar syntax. So in Dart, you have class segment, integer. Okay, so we have a class with some field and a string with interpolation. And they're comparing that in Kotlin, it's very similar, and Swift is similar, and TypeScript, it's similar. Alrighty. That sounds good. Righty. Just checking if everything is fine. Guess it is. All right. So next step would be productive development. Make changes to your source code iteratively using hot reload to instantly see the effect of the running app. Okay, so I guess you change the documentation, whatever, it reloads and you see it. Probably also is for your mobile app, which would be fun. Write code using flexible type system with rich static analysis and powerful configurable tooling. String can be assigned to an int. Duh. Dart names types using upper camel case. Okay, so we have some style checks and whatnot. Okay. Type of temperatures inferred to be int. Yep. Okay, the standard stuff. Do profiling, logging, and debugging with your code editor of choice. Okay. All right. Well, I guess we'll learn which editors those are. Fast on all platforms. AOT, ahead of time compile apps to native machine code for instant startup. Okay, Dart compile, exe, hello Dart. And we get a Windows app, right? And yeah, that started up fast. Target the web with complete mature fast compilers for JavaScript and WebAssembly. Okay, WebDev serve, WebDev build, nice. Run backend code supporting your app written using a single programming language. Okay, oh, that's actually an interesting part. I wonder how a language like this would work with backend. So try Dart in your browser. There we go. We have a function main with a for loop from 0 to 10, whatever, from 0 to 9. And hello. And just print, right? And we have, I guess this is supposed to be string interpolation. Then we see it somewhere up here. Yeah, so this is like a normal string, but the $sign instantly makes it into something that's going to be executed. So that run, right? That's great. What if I'm going to just do this? Run. Yep, that works. So my A will be like already error. There's no name. So just a $sign within a string already makes it. But I guess I could do this and yeah. Okay. Already know how to string interpolate. That's fun. Okay, this is simple. And we have samples, right? We have nice Fibonacci. Okay, primitive Fibonacci, and we are actually calling it from within string interpolation because why not? Yeah. Compiler is supposed to optimize that, right? Okay. So first thing I noticed that I like is that okay, this language allows me to basically uh, you know, have my definition later. So it's not like you have to do weird ordering stuff. So that makes me happy. Just need to keep monitoring chat. Okay, so yeah, this is simple and fun. Hello world, we saw that one. Okay, so that's just pure Dart. Then we have Flutter, like a counter, right? Can run it, and this will probably show up as a web app. Yep, there you go, counter. I wonder how difficult it is to make like complex web applications using Flutter as compared to, for example, something like Quasar Framework for interfaces. Very curious. But yeah, in this case, import Flutter. We just set up the app and we just provide a class, my app, which is the status widget. Okay, so we're already dealing with widget because I don't know, for some reason with mobile apps, they like to call everything a widget. I never made like a mobile app ever. So uh, that's that. And we just override the build, which I guess is what we set up. The material app, we have title, debug show check mode banner. How about true? And reload. There you go, debug. That's fun. Color scheme, blue. Will I see what other colors there are? There we go. Nice. Okay, I like that. I don't like teal. It's just the red. Bam. And we have everything reddish. So that's great. I like that. Very simple. Instant instant material design, I guess. And yeah, home is my homepage. And my homepage is defined here as another widget. So there will be another builder here. But no, we are not overriding build. So we have the title, my homepage, and override the create state as my homepage state. Okay, so this definitely needs a tutorial. But at the same time, the state is not a lot because it's just a state. We have the state of the counter and provide a function to increment it, right? So set it. So, okay, this is like a simple, you know, store for state. Oh, and the state provides the build for data. So I wonder if you can just keep changing state and don't know. But okay, this does something. So this is really simple, yeah. And we have the alignment center and whatnot. I guess they're trying to show off that you can center things in the middle easily without CSS. Okay, great. And sunflower will be probably something more visual, animated or whatnot. Yep. Oh, look at that. Fun animations. And how are they making animation? Literally moving them? Oh no, it's again widgets, so this is all Flutter. Huh, interesting. I wonder if this would open up some possibilities of making something fun. Yeah. And other than that, we have, I guess, one more ecosystem, Flame Game. What is uses probably Firestore or something. And Flutter, Brick Breaker. So we basically have a bunch of imports of Flutter and some other Flame stuff. So I guess other things for this game, and you end up having an entire game, right? That's kind of fun. There you go. Oh, you just move it with arrows. There you go. No sound though. Does it work properly? Kind of. Okay, so the moment it goes to the edge, it moves a little bit faster, but not much. Okay, so we've got that. And of course, you can ask Gemini to change it so they have full on integration. Why not? Okay. So, when practice learn the language, explore the core libraries, or build command line app. So, we will learn the language, but I want to see what's around else here. So, we have the overview. I guess that's it, right? Oh, there's more. So, we have an overview. Let's just switch to dark mode because this hurts my eyes. Although I should probably light my face up a little bit more for your sake. Or maybe quite the opposite. All right, so yeah, let's go through overview. Dart overview. Dart is a client optimized language for developing fast apps on any platform. Its goal is to offer the most productive programming language for multi platform development paired with a flexible execution runtime platform for app frameworks. Languages are defined by their technical envelope. The choices made during development that shape the capabilities and strengths of a language. Dart is designed for a technical envelope that is particularly suited to client development, prioritizing both development, sub-second stateful hot reload. Both prioritizing both development, so that we have a less than a second hot reload that saves the state so that your state of the app doesn't change, and high quality production experiences across wide variety of compilation targets like web, mobile, and desktop. Dart also forms the foundation of Flutter, whatever you pronounce it as. Dart provides the language and runtimes that power Flutter apps, but Dart also supports many core developer tasks like formatting, analyzing, and testing code. So Dart the language. The Dart language is type safe. It uses static type checking to ensure that a variable's value always matches the variable's static type. Sometimes this is referred to as sound typing. Although types are mandatory, type annotations are optional because of type inference. The Dart typing system is also flexible, allowing the use of dynamic type combined with runtime checks, which can be useful during experimentation or for code that needs to be especially dynamic. Okay, I wonder how that works, to what extent we can do dynamic stuff, and how easy slash pleasant it is to use. Because I run into need of that sometimes, maybe a little bit too often. I mean, often when you start hitting that, that means that you try to do something wrong. But sometimes there's kind of no going around, and trying to fight it would be where you know, you're doing something wrong as well. Oh well. Dart has built-in sound null safety. This means values can't be null unless you say they can be. That's awesome. With sound null safety, Dart can protect you from null exceptions at runtime through static code analysis. Unlike many other null-safe languages, when Dart determines that a variable is non-nullable, that variable can never be null. If you inspect your running code in the debugger, you see that non-nullability is retained at runtime, hence sound null safety. The following code sample showcases several Dart language features, including libraries, async calls, nullable and non-nullable types, arrow syntax, generators, streams, and getters. To learn more about the language, check out the Dart language tour. We will definitely do that. Let's take a peek. So import Dart math, show random. So what, we're importing entire thing, but making this like a instantly available or something? Not sure what show means yet. That's interesting syntax. And then we define our, I guess, our main function, which is asynchronous, which is already fun. So we have top level as, let's call it top level async. We can print stuff and we can await for. Ooh, that's nice. Await for. Hmm. I think I saw await for only in C# so far. So that's kind of cool. And then we have a final estimate in compute pi, take 100 entries. And then we do that. What? Oh, compute pi is probably the async, right? Yeah, this is an async. Okay. That's why. So we basically uh oh, so this is a generator, right? This is a generator from which we can take 100 entries, but this is asynchronous generator, so we don't know how long it's gonna take. So this is gonna take a while. We don't know how long. So that's why we have to wait for the for loop because it's an asynchronous operation. That's fine. Okay, so our generator, it's basically returns a stream of doubles. Okay, generates a stream of increasingly accurate estimates of pi. Okay, and a batch of 100,000 by default. We didn't change that. Okay, and then we have async star. Wonder what star does here. And then invert to be type int. Yep, yep. And then we have while, and we do turn random. Oh, that's another generator. Huh. So we take 100,000 random numbers, right? So these will be our points. Uh, okay. Then we filter the points where the point P is inside unit circle, and bam. Where does inside unit circle come from? Maybe the math. That's interesting. But okay, great. So we just filter them out. In total is we just add the number because this is our loop, right? This is still within our loop. So we increase the total by 100,000. We can't count inside how many there are. And ratio, bam. We have therefore some math to do. And yield ratio by 4. So this is basically, uh, you know, by yield is standard thing in generators that we just yielded the first value to return. And therefore, yeah, and therefore the first value was done. So if we ask for 100, we did 100 thousands points. That's a lot. Okay, I guess that's why it takes time. And we have total and count. Okay, all right. So we basically keep generating random points. As long as they are truly random, we start estimating better and better how many there are inside the circle and how many there are not inside the circle. Okay, cool. Okay, here we have the generate random, right? So final random, we get the random seed. While true, we just return the random point, right? Keeps going here uh, until forever. But because it's a generator, we just keep yielding, and looks like we don't have to handle any logic for stopping it or collecting garbage or anything. It all looks automatic. So that sounds good. And finally, we have the point. Yeah, that we were generating. It's a 2D point. Okay, so that's our class. And I keep seeing the final, which is like a constant, I assume, because that's what it makes sense would make sense here. Even though we have constant here, whatever. um, but I guess something can be assigned once, right? So Yeah, curious about that part. And start a circle and run. And there we go. We quickly got to pretty accurate number, right? Scrolling isn't the greatest. Yeah, we started from pretty good estimate and getting closer, further. I mean, it's kind of all over the place. So this would need a lot more time. I guess if we were to increase the batch size, that would be a little bit different. If we were to increase the batch size by adding 3 zeros, that could help probably in accuracy a lot. But now our computer is firing up. Okay, that's gonna take some time. In the meantime, this example is running in an embedded Dart pad. You can also open this example in its own window. Great. That's fun. I like that. Dart, the libraries. Dart has a rich set of core libraries providing essentials for many everyday programming tasks, built-in types, collections, and other core functionality for every Dart program. Okay, so that's your Dart core. Richer collection types such as queues, linked lists, hash maps, and binary trees. Dart collection. Okay, encoders and decoders for converting between different data representations, including JSON, UTF-8, and whatnot. Dart convert. Okay, mathematical constants and functions, and random number generation. Dart math. Support for asynchronous programming with classes such as future and stream. Okay, so that's Dart async. Okay, I like that. This is still running. I hope I'm not breaking up out there. So what else? Ritual collection. Yeah. Mathematical constants. We went through lists that efficiently handle fixed size data. For example, unsigned 8-byte integers and SIMD numeric types. So be typed data. Okay. I'm surprised to see things that quite quickly go to a little bit of a lower level, right? I wonder I wonder how much is implemented in Dart itself and how much is maybe going straight down to C code. I really wonder. File, socket, HTTP, and other I/O support for non-web applications. Dart I/O. Okay. Foreign function interfaces for interoperability with other code that presents a C-style interface. Okay. Concurrent programming using isolates. Independent workers that are similar to threads but don't share memory, communicating only through messages. Okay, I like that. Nice and separated. HTML elements and other resources for web-based applications that need to interact with the browser and the document object model. All right. This is still running. Oh dear. Um, hmm. Beyond the core libraries, many APIs are provided through a comprehensive set of packages. The Dart team publishes many useful supplementary packages, such as these: Characters, International, HTTP, Crypto, Markdown. Okay, additional third-party publishers are the broader community, and the broader community publish thousands of packages with support for features like XML, Windows integration, SQLite, compression. I am seeing a lot of Windows mentions from the front page to already second page, and XML for some reason. Hmm. To see a series of working examples feature Dart code libraries, read the core library documentation to find additional APIs, check out commonly used packages page. Commonly used packages. Interesting. I like that. Not just, uh, okay, here's the overall packages, figure out what people use. Here's commonly used. I mean, that's not a lot, but hey. That's fun. And then we have Dart platforms. Dart compiler technology lets you run code in different ways. You have the native platform for apps targeting mobile and desktop devices. Dart includes both Dart VM with just-in-time compilation and ahead-of-time compilation for producing machine code. Okay. Native web platform for apps targeting the web. Dart can compile for development or production purposes. Its web compilers translate Dart into JavaScript and WebAssembly. So we basically have development toolchain and production toolchain. So development is for fast incremental compilation, stateful hot reload, while production is for basically fastest native output and smallest runtime. All right. And overall, we have Dart native. So I guess our native code and Dart web. So it was JavaScript for the web. And then we have basically pretty much all the platforms for native code. All right. And the Flutter framework is a popular multi-platform UI toolkit that's powered by the Dart platform that provides tooling and UI libraries to build UI experiences that run on iOS, Android, macOS, Windows, Linux, and the web. Yep, I'm curious about that. How much you can actually, how easy it is. So a little bit more about Dart Native. During development, a fast developer cycle. Just a second, I heard a lot of noise. I guess everything's fine. Sorry about that. So during development, a fast developer cycle is critical for iteration. The Dart VM offers a just-in-time compiler, just-in-time with incremental recompilation, enabling hot reload, live metrics collections, powering DevTools, and rich debugging support. Okay. When apps are ready to be deployed to production, whether you're publishing to an app store or deploying to a production backend, the Dart ahead of time compiler can compile to native ARM or x64 machine code. Your ahead of time compiler app launches with consistent short startup time. So I wonder how small you can get the app to be. Because I like to, for example, make very small little services that I can deploy via Docker on my local home lab, right? And I don't want, each container to eat up like 200 megs of RAM just so that I use it, once a week or something. Yeah, I wonder what the footprint of, let's say, tiny web server would be if it was compiled to, let's say, Linux code, whatever, and deployed on some bare bones Docker container. Curious. Maybe it will be a little bit more feature rich alternative to something like Go. The ahead of time compiled code runs inside an efficient Dart runtime that enforces the sound Dart type system and manages memory using fast object allocation and a generational garbage collector. Some more information, we have some command line and server apps. Dart tool for running just in time and ahead of time compiling the machine code, write command line apps, and write HTTP servers. I really like that it just gives you tutorials. This is like nice set of links for all the quick little things to get you started. And then we have Dart Web. So for Dart Web, let me just check comments. Nobody's saying hello. Oh well. Dart Web enables running Dart code on a web platform powered by JavaScript. With Dart Web, you compile Dart code to JavaScript code, which in turn runs in a browser, for example, V8 inside Chrome. Alternatively, Dart code can be compiled to WebAssembly. Dart Web contains 3 compilation modes: an incremental JavaScript development compiler enabling a fast developer cycle, an optimizing JavaScript production compiler which compiles Dart code to fast, compact, deployable JavaScript. These efficiencies come from techniques such as dead code elimination, and an optimizing WebAssembly production compiler, which compiles Dart code to supervise deployable WebAssembly GC code. Okay. So you get like, how much performance you want. Let's see if this has finished yet. Not yet. What the hell? I just added 3 zeros. It should be, in worst case, 1,000 times slower, but guess not. Uh, it's not like Chrome is using much of CPU, nor much of memory. Nope. It's not doing much. Let me refresh the page, and maybe it's going to calm down. It probably just stopped even executing. Okay, so we went through that. Great. And we have more about web apps, compiling to JavaScript, more tips, or straight up jump into WebAssembly. All right. And lastly, we have the Dart runtime. Regardless of which platform you use or how you compile your code, it's doing something. Regardless of which platform you use or how you compile your code, executing the code requires a Dart runtime. This runtime is responsible for the following critical tasks. Managing memory. Dart uses a managed memory model where unused memory is reclaimed by garbage collector. Enforcing the Dart system. Although most type checks in Dart are static, some type checks are dynamic. For example, the Dart runtime enforces dynamic checks by type check and cast operators. Managing isolates. The Dart runtime controls the main isolate where code normally runs, and any other isolates that the app creates. Okay. On native platforms, the Dart runtime is automatically included inside self-contained executables and is part of a Dart VM provided by the Dart run command. Okay. And now you have many choices for learning Dart. Here are a few recommended. Explore Dart in the browser through Dartpad with basic execution. Take a tour of the Dart language. Complete Dart tutorial. Work through extensive online training, which takes us to Udemy. Explore AI documentation. Read book about Dart programming. Let's see the book. If you find Dart book, not listed in this page. Oh, okay. So this is like go and buy a book, right? Yeah. Let's take a peek at the first one and yep, go buy a book. Go buy a book, basically. Everything by Jonathan Sunday. Okay, so these are the books, but I'll start with a tour of the Dart language. This way we can close this tab and start in a new one. All right, so looks like we're finally getting a little bit into the actual learning of the code. So what we'll learn? We'll learn, go through introduction, variables, operators, and comments. Then we're going to go through a bunch of types, some patterns, control flow, functions, metadata, libraries, imports, classes and objects, standing, mixins, enums, extension methods. Yay! Okay, cool. Class modifiers. All right, and concurrency. Great. Null safety. Multiple pages. Good to see. And keywords. All right, so that's like the overview of the language, I guess. Because then we have core libraries. Yeah. I guess that's a tour of the language, right? That's what we clicked. And go to docs, language tour. Yeah, that's it. Okay. All right. So this page provides a brief introduction to the Dart language through samples of its main features. To learn more about the Dart language, visit the in-depth individual topic pages listed under language in the left side menu. For coverage of Dart's core libraries, check out the core library documentation. You can also check out the Dart cheat sheet for a more interactive introduction. Let's just take a peek. How is it interactive? Oh, by having a bunch of examples you can run. Okay, that's all. All right. Uh, all right. So hello world. Every app requires the top level main function. Okay, so we can't skip main. So they're still catching up with C sharp. Uh, where execution starts. Functions that don't explicitly return a value have the void return type. To display text on the console, you can use the top level print function. And that's it. Read more about the main function Dart, including optional parameters for command line arguments. So that's that. You can copy it. I guess we can run it right here. Wasn't there like try Dart? There we go. So in theory, I can copy this, plop it here, and run. It will be hello world, right? Great. Okay, so we'll use that as a little scratch pad to try out weird stuff. So they say this is a function, so I should be able to do void say hello, right? And just put it here. And instead of that, just to say hello. And I need a semicolon. Okay. All right. Works the same. Great. Okay. Variables. Even in type-safe Dart code, you can declare most variables without explicitly specifying their type using var. Thanks to type inference, these variables' types are determined by the initial values. Okay. So this looks nearly exactly like C#. That's funny. So we have some kind of string, some kind of integer, I presume, some kind of floating as such double. Wonder what it defaults to. Then we have a list / array. What is the proper naming convention here of strings? And then we have entire object with where the keys are strings and values could be various things. So this is more like a JavaScript object. I wonder what they call it. Alrighty. And hello, Taras. How are you doing? It's good to see you here. I don't know if my chat overlay works. It might not. Alrighty, so I'll read more about variables in Dart, including the default values, the final and const keywords, and static types. Okay, so if final and the const keywords are separate, and they both can be applied to a variable, that means that final is probably just apply once, like set the value once, and you can't change it. While const is that you need to have the value actually defined in a more static manner. I wonder if const is like specifically it needs to be actually computable during compilation. Curious. We'll learn about it. Then we have control flow statements. Dart supports the usual control flow statements. All right, we have our if, so we need it to be in parentheses. Okay, good to know. And no comparison to this, else if that. Okay, that looks normal. Then we have our for loop. So for something object in flyby objects, so we can iterate over lists using the in keyword. Okay, it's not like JavaScript with their weird off keyword. Then we have for, just your regular, and our while, and that's it. Okay, so this doesn't require much learning. This is like so many other languages. Copy paste. Okay, as this specific live stream is about me learning Dart, I won't go in depth in those right now because I understand it. So, I'm not recording a tutorial. But let's see. Read more about control flow statements in Dart, including break and continue, switch and case, and assert. Okay. So assertions, I guess we can just stop the program from running, as in, oh, this was supposed to be that, it wasn't. Panic. Break and continue, that's just for loops. And switch and case, of course, our switch statements. I presume that switch and case is where we have our patterns and pattern matching. We'll see. Okay, then we'll get our functions. We recommend specifying the types of each function arguments and return value. So we recommend, so it's optional, but yeah, I'd recommend specifying them as well, because it, when you're defining a function, it's like you're defining some kind of contract of, hey, this, whatever's inside here, no matter what's inside here, it takes this, returns that, and that's it, right? So this is like an overview for you, that's how it's supposed to work. Just the name and what it takes and returns should be enough for you to have an idea what this thing does. Therefore, you shouldn't be concerned about that. If you suddenly don't have return type as, I know, var or something, therefore it's inferred, yeah, it wouldn't be great. So we recommend specifying the types of each function's argument and return value. So let's just try it, because we have this, right? This will just probably not do anything, right? We don't have main. So let's undo, let's plop it here. So we define our Fibonacci, and in our case, we will just say that, hey, the result is a Fibonacci 20, and we'll do print, and it'll be result is this, right? This should be simple enough. Should work. Yes, there we go. But what if, because I should be able to do var, right? Missing type annotation, but that's just a warning, right? It still works. So let's put it back to end. What if I'm going to do var here? The return type cannot be var. So the return type cannot be inferred. Okay, I guess it's not TypeScript, right? Although in TypeScript, considering how complex the type system is, sometimes it's actually very welcome to have it as var. But oh well. Okay, so return type needs to be defined. The argument types, in theory, don't have to, but please do. All right. And Tara says, by the way, I use either final or explicit type no var. But you can commit type completely. I mean, return type completely. Use either final or explicit type. So you can do final as in... No, that's for variables. So I could do this, right? Run. That'll be fine. Yeah, because var suggests that I can do result is 12, right? And it should be fine. And I just rewrote it. If I'll do final, I assume that it won't be possible, right? The final variable can only be set once. There we go. But if I'll try to make it constant, it'll probably complain because it can't run it, right? Yeah, methods can be invoked in constant expressions. There we go. Too bad it doesn't have like Nim has, where you can just, the compiler can actually run it for you, so you have it like super extra optimized. But okay, I understand the thing now. That's awesome. Okay. Oh, you can omit the return time completely to call it like this. Ah, okay. Run. Okay, so it does that. All right, so that's good. Okay, I wonder how often it is helpful. But probably not recommended unless you're doing some crazy weird wrappers, maybe, and then some separate helper library that could be helpful, but other than that, I don't know. Okay, so that's great. A shorthand arrow syntax is handy for functions that contain a single statement. This syntax is especially useful when passing anonymous functions as arguments. So float by objects and we basically have our filter function here that takes name and returns something for each print. But I want to check that. So what if I'm gonna do whatever constant fly by objects, right? And I should be able to say that it's go straight, turn right, and whatever, right? So I have this thing. I have a list of those. Therefore, I can filter them out. And for each one that contains the turn, name contains, for each one, I will just print it. Interesting. So if you call print without anything, the thing will be injected in there? Or this is actually considered, because it takes a function. For each takes a function. Okay, so if I'm going to run it, it will say turn right. Okay, great. But can I do this? As in straight up screw the one line? Isn't returnable from, wait, what the hell is going on here? Name contains turn. And we close it. So in theory, no. I guess we'll get to proper syntax of the arrow functions. Let's see what Taras is doing. Is it for local functions defined in other functions? Okay. The omitted return type. Okay. Const is only for primitive types, and yep, this is a list. A list is not primitive and can't be const. How did I make it const then? Interesting. What do you have? Yeah, I have a const list. Yeah. You never use const. Yep, that's what it is probably. This thing. All right, so let's get back to the ideas here. We'll get into proper syntax because I like arrow functions and I like sometimes making them large. Besides showing an anonymous function, the argument to where this code shows that you can use a function as an argument. The top level print function is an argument to for each. Yes. We notice that. Read more about functions in Dart, including optional parameters, default parameter values, and lexical scope. Okay. Wonder how scope is managed. Hopefully, normally. In comments, just double slash and triple slash is a documentation command used to document libraries, classes, and their members. Tools like IDEs and Dart doc tree doc comments especially. And you can also do slash star or slash asterisk to make longer ones. Okay. And looks like there's documentation tooling, which is great. So let's skip to imports. So now basically Access API is defined and other libraries use import. Importing core libraries. Import Dart math. Libraries from external packages. Okay, so core libraries just begin with Dart. External packages start with package and then something. Or importing straight out of files, so path to my other file.dart. Okay. This is interesting that here from some other package test, right? I guess this is always package. I assume always will be word package. And then we have, I don't know, name of the package and somehow a name of a file, which is interesting. Then read more about libraries and visibility in Dart, including library prefixes, show and hide, and lazy loading through the deferred keyword. Oh, we've got lazy loading. That's fun. Then we got classes. Here's an example of class with 3 properties, 2 constructors, and a method. One of the properties can be set directly, so it's defined using the getter method instead of variable. The method uses string interpolation to print variables string equivalents inside of string literals. Okay, so we've got a class spacecraft, right? We have a field name, which is a string. Okay, so a string type is capital S. Good to know. Date time is, this is an optional one, right? I presume. So a nullable one, right? Launch date. Okay. Our spacecraft can have or might not have a launch date. Then we have read only non-final property. So the integer, which might be nullable, I presume, get launch year, which returns launch date. Oh, just the year of launch date. Okay, so this is like a simple getter. This is purely a getter. So sure, we can call it property. I will just call it a getter. I guess that's my C# way of looking at things. And I've got a constructor with syntactic sugar for assignment to members. Okay, spacecraft, this name and this launch date. And initialization goes here. So yeah, this dot name and this dot launch date basically makes it that we instantly assign those that were passed in those spots, I presume. So this is similar to C# as well. Then we've got, or like I believe records do that in C# or something. They've got named constructor that forwards to the default one. Spacecraft unlaunched. So named constructor that forwards to the default one. So spacecraft dot unlaunched. Ah. So I guess because it starts with spacecraft on its own, it is also a constructor, and the dot something, it makes it named. I kind of like that we have those named constructors that we can refer to. They still act as constructors. Therefore, you probably use the new syntax or something of this sort. And yeah, we don't have to have like do weird shenanigans if you have to have million variants of constructors. Okay, I like that. Then we've got a method, which is just like a function description, right? Name. Okay, so we're printing out name. So name is just available straight away. We don't have to do any of this dot name or anything. It's just available instantly. Okay. Not sure if I like it. But look at that. This launch date uses this. That one doesn't use this. The promotion doesn't work on getters. Launch date is this dot launch date. If launch date is not null, and here's is datetime now difference launch date in days. Type promotion. What on earth is type promotion? I have no idea. Uh, because launch date is not a getter. So here we're defining a variable, local variable with the same name as this. Therefore, that's why we're referring ongoing we would need to refer to those separately. Okay. I feel like I need to test something. So let's try to do something of this sort. Let's say we have class car. Okay? Something really simple. And a car has a I don't know what cars have. Integer wait, wheel count, right? And by default it's 4. Can I do it by default? Default value? Please? Yes, I can give it default value. And then we would have maybe string, which is the brand, and string, which is small. And now this is unhappy because of reasons. So let's just do print by. Okay, just like that. Now brand is unhappy because it must be initialized and model must be initialized. So that's why we probably need to create car. Wait, do we have some kind of keyword for constructor? No, just a method like that. Okay, it looks like a method. So car that takes this dot brand and this dot model. Okay. Do we need a semicolon at the end? No, we don't. So we have the constructor. Therefore, we can basically do, I don't know, final. My car is how to create a car just like that. We don't have any new keyboard. And how does it say? Just skip it. It's about inference of nullability. You also do not need empty square brackets. You mean I can just skip those? No, I can't do those. Square brackets. Unless. Oh, this works. Okay. All right. So my car is car, which is. I know a brand will be Toyota and model will be Civic, right? There we go. And this should work. So I should be able to print my car is my car dot model made by my car dot brand. It looks like it ends here, so I guess I would need to put parentheses around it. No. Huh. That's interesting. When I run it, my car is an instance of car model made by instance of car brand. Yeah. So we had the dots. Okay. I'm sure there's a way to do it. I just am not aware of this right now. This looked like something for a second. This might be it. Just fiddling with it. Run. There we go. That works. Let's see what Tara said, because he has tips that are probably outdated already, right? You also don't need empty square brackets. Skoda Fabia. uh, wow, nobody in the US probably knows Skoda Fabia. Yep. Yep. Figured out the the stuff. Okay, so that's simple. So now my question is, if I'll say something like void do fun, right? And let's say what do I want to do? I basically want to see if I can refer to those things in some specific ways. So can I do print brand, right? I should be able to do just that. So let's just do my car do fun. Run. Okay, so I did that. Can I do this dot brand? That worked as well. So in theory, I can make a final brand, like my own version, to just shadow it, right? It will be this dot brand plus voila, right? Let's see if just adding with a plus works, or we need to do something weird. It's not used, so we're going to do that, and therefore we're going to use the local variable that shadows the other one. Okay, so that works. That's what we're seeing there. Okay, interesting. That explains it. And type promotion doesn't work on getters. Type promotion was supposed to be the thing, so we're going to learn about that. If launch date is not null, then we're going to do stuff, right? Otherwise, do that. So, wonder what that means. I assume it means something where we can't use the launch year for some reason. Okay, but no big deal. And date time now, difference, launch day and days, blah blah blah. And we do some fancy stuff here. Okay, that's easy. So read more about strings, including string interpolation, literals, expressions, and the toString method. You might use the spacecraft like this. So we create new spacecraft with the data, and we can describe it, and then we can use the specific named constructor, which, okay, I don't mind that syntax. Sure. And that means that we still can use the syntactic sugar here, right? There we go. And for the default one, okay, so it forwards to the default one where this is set to that and this is to that. So I guess the default constructor needs to set everything. Okay. And then the other ones do their own stuff. Can I do something before I forward? I'm sure it's possible, but who knows? So what's next? Okay, read more about class and Dart, including initializer lists, optional new and const, redirecting constructors. Interesting. Factory constructors, getters, setters, and much more. Okay, I am excited about those features. This actually is nice. Yeah, fun. Enums. Enums are a way of enumerating and predefine a predefined set of values or instances in a way which ensures that there cannot be any other instances of that type. Here is an example of simple enum that defines a simple list predefined planet types. So already here, Taras, I hope that this is done decently here, because so many languages miss out on decent enums. Enum, planet type. We can have terrestrial, gas, or ice. Okay, so these are just keywords that we specify, no string, nothing weird, just like that. Here's an example of an enhanced enum declaration of a class describing planets with a defined set of constant instances, namely the planets of our own solar system. So enum that enumerates the different planets in our solar system and some of their properties. So we have enum planet. So we have Mercury, and that's just a name we gave it. It's not defined anywhere, and it just contains extra fields. Wait. Oh, okay. So our planet type is defined here, right? Terrestrial, gas, or ice. Planet type is planet type terrestrial, moon 0, gas rings this. So we have like those composite enums. Okay. All right. So I like that. Little lookup tables. And then a constant generating constructor. A planet. Required. This planet type, this moons, and this has rings. A constant generating constructor. Oh. Oh, I see. So we have an enum on which we define those fields, right? All instance variables are final. Okay, so this is like a little class at this point. So an enum can contain a set of variables, all right? Therefore, we can predefine some of the specific values like planet.mercury, right? To get instantly something. Or we can create a constructor that will return those. And because these are enums, each variant that, reuses the, like if you're gonna call this constructor 5 times with same set of provided values, you're gonna get the same object, same constant object. Okay. And then it has support getters and other methods. Yeah, just a bunch of helpers to do stuff. Okay, this is nice. I like it. And yeah, okay. Wonder how much we can also tie it to other things, but this is fun. This is fun. It's nice and typey. And Yosef Samir on YouTube is asking, "Hello, how are you? Are you a beginner? Will you use Dart and Flutter or backend?" Uh, probably all over. I'm beginner to Dart. I'm not beginner to any sort of programming. Just trying to quickly inject some Dart into my head to quickly move around projects to not be slowed down by a different language. Get a decent overview. Okay, so you might use the planet, like this. Finally, your planet is planet Earth, right? So we just retrieve the constant Earth. Or if your planet is giant, so we're using getter, something. Great. Read more about enums and Dart, including enhanced enum requirements, automatically introduced properties, accessing enumerated value names, switch statement support, and much more. Great. The switch statement and pattern matching, this combined with that would be great. Okay, inheritance. There we go. Dart has single inheritance. Okay. Class orbiter extends spacecraft. Good enough. So double altitude and orbiter super dot name. Okay, so we create a subclass of spacecraft, orbiter, right? Specific type of spacecraft. We add a property altitude to it, and we create a constructor, which basically, as a first argument, it takes a name, which will be passed on to the parent constructor. The same with the launch date, and then it specifies this altitude. So if we need to specify things like this and super, I wonder if it's possible to actually shadow uh, fields in the class itself. So what if, given my class car, if I'll say class, I don't know, uh, sure, supercar, right? I'm gonna say that I'm gonna make because I can add extra property, right? Maybe and spoiler count, right? And that will be whatever 16 by default, right? So I can tag that on, and let's say I will make it without a default, so it will force me to create a constructor, right? So I do supercar, and I need to pass on super.brand, super.model, and this dot spoiler count, right? To make it happy. Uh, Positional superconstructor parameter. How so? Super and super. Brand and model. Brand and model. No associated positional superconstructor parameter. Try using normal parameter or adding more positional parameters to the superconstructor. Hmm. Hmm. That's a surprising one. Did not expect that one, to be honest. Oh. Ah. Duh. Thank you, Taras. I missed extents. Oh, wow. I missed the entire point. All right. So that's that. But what if I'm going to do, let's say, int model? Program model and function is in the valid override. So, can I do this dot model here? Model is already defined. Yeah, this will be probably a bit more curious. But the setter is an invalid override of car model. Let's say equals 16. Can I just... No, I can't. Ay, and now it all falls apart. Yeah. I'm trying to do stuff that I shouldn't even be thinking of right now because it's just trying to break the language. Alright, never mind. Read more about extending classes, the optional override annotation, and more. Maybe the concept of mixins. Mixins are a way of reusing code in multiple class hierarchies. The following is a mixin declaration. So mixin piloted. So we have an integer astronauts is 1. And describe crew number of astronauts is this. To add a mixin's capabilities to a class, just extend class with a mixin. The class piloted craft extends spacecraft with piloted. Okay, so we just inject the two. Piloted craft now has the astronauts field and the described crew method. So how is it different than an interface? Because it has both. Oh, because it has a field and uh, some kind of already a method with predefined logic, probably, right? That's why. Both field and logic included. Well, interface will only define that we have described and something else. So let's see. So interfaces and abstract classes. All classes implicitly define an interface. Therefore, you can implement any class. All classes implicitly define an interface. Therefore, you can implement any class. Okay. Oh. Okay. I like that. That's helpful. Class mock spaceship implements spacecraft. Oh, I really like that. Read more about implement implicit interfaces or about the explicit interface keyword. You can create an abstract class to be extended or implemented by a concrete class. Abstract classes can contain abstract methods with empty bodies. Yeah, so we have abstract class, describable, which has the describe, and then a scribe of emphasis that already has the logic in it, right? Okay, that's simple. Any class extending describable has the describe of emphasis method, which calls the extended implementation. Excuse me. Of describe. So I guess I could override, implement this in the abstract. I wonder if I could override this one in the actual implementation of the class. Yeah. Okay. This surprised me. This is fun. Could save a lot of time and extra files and just uh, you know, ceremonies. Okay, so let's move on to async. Avoid callback hell and make your code much more readable using async await. Okay, I expect that async await will be very standard because it usually is. And so far, language seems to be quite polished. So, yeah, I'm starting to have expectations. That's dangerous. All right, so constant 1 second duration seconds 1. Okay, so we learn how to create durations. Okay, so 1 second duration, and we have the future return time. Okay, so I guess in C# that will be task, in JavaScript that will be a promise, right? Print with delay. It takes a message, okay, and it's an async. So we put the async keyword at the end for some reason, and we can await for the delayed future. Okay, so looks like our future might have a set of things. All right. Uh, so we just delayed. So this just waits for a second and then prints a message. No big deal. The method above is equivalent to future void print of delayed. Bam. Return future delayed 1 second. Then this. Oh, we have straight up like JavaScript like then with arrow functions. I did not expect that, but why not? You can suddenly looks like you can still return futures and deal with those with non-async stuff, non-async functions. Um, Although I don't know if that would change anything because something tells me that you can still use those the same way because in theory they both return a future. So as from a person like perspective of a C# user, in theory I could within my async function I could call this print with delay here, the one that is async with await, but I could also do this one because what you're doing is you're awaiting the actual return type, the future. Interesting. As the next example shows, async and await help make asynchronous code easy to read. So again, we return a future, create descriptions, iterable string objects. Okay, so we have some kind of iterable collection here. And async. So we iterate over the objects, all right, which are just strings. And what? We basically get a file with that name. We wait if the file check exists, right? So I like that we can await it right within the if. Then we can basically wait, check when it was last modified. Oh, I like this is a nice little interface. I like that for dealing with files. Print it and continue. Then we create file, write a string, get a bunch of awaits. We have exception, and looks like we don't have to deal with any, weird stuff. Nice and tidy. I like that. You can also use async star or asterisk. Awesome, which gives you a nice readable way to build streams. Okay, so the asterisk is specifically for streams. Okay, so we have a stream of strings that we're returning instead of just a future. So report, spacecraft, then list of objects, and this is a async asterisk. So for final object node, so we iterate over all the objects. We basically wait for a second, yield the name of the spacecraft, flies by, and name of the object. Okay, so if we have the async, we basically keep yielding, right? And therefore, this is returning a string. So we basically turned it into. I wonder if it, from the perspective of Dart, this is simply a generator. I wonder if this is simply considered a generator, like any stream is just a generator, right? An async generator, and we keep yielding. We have the same sort of syntax. And after we run out of them, we just have returns, so the stream finished, and therefore we're done, right? And async just finishes completely, unless we did async for loop, where we were able to iterate over things in a little bit more swift way. Okay, so read more about asynchrony support, including async functions, features, stream, and the asynchronous loop. Wait for. Okay, I like this. This is nice, tidy, simple. Doesn't give an impression that there's lots of edge cases so far. So yeah, great. Next, exceptions. To raise an exception, use throw. Throw some kind of error. Bam. No big deal. To catch an exception, use try statement with on or catch or both. So future, describe flyby objects. Again, async. So what we're doing is we're doing the try catch loop. We're doing some shady stuff here that might cause errors, right? Because hey, maybe the file doesn't exist, right? And then we have on IO exception catch error. Okay, so the on is used to specify the type of an exception we want to filter, and then what object we catch it as, right? Could not describe object, bam. And then we have finally. Now that the code above is asynchronous, try works for both synchronous and asynchronous code for an async function. Read more about exceptions, including stack traces, rethrow, and the difference between error and exception. Oh, that's fun. Error and exception. Look at that. Simple. Great. Okay, we're near the end of the introduction. Look at that. So far, it's a nice overview. I like that they're not doing like, oh, go through the most basic basics from the nitty gritty little teeny tiny things, where you're spending 2 hours doing the simplest things. This is a nice overview where it goes over actual advanced features, targeting not a noob, but somebody that knows what they're looking for in a language. So, yeah, I appreciate that. Okay, for the concept. As you continue to learn about the Dart language, keep these facts and concepts in mind. Everything you can place in a variable is an object, and every object is an instance of a class. Even numbers, functions, and null are objects. Okay. That is interesting. Even numbers, functions, and null are objects. So that means that we don't deal with okay, interesting. We don't have the differentiation between type values and object values. Okay. With the exception of null, if you enable sound null safety, all objects inherit from the object class. Okay. So the sound null safety needs to be enabled. It's not enabled by default. Are you serious? Version note. Null safety was introduced in Dart 2.12. Using null safety requires a language version of at least 2.12. When was 2.12 released? Is that a new feature? Okay. Next, we have, although Dart is strongly typed, type annotations are optional because Dart can infer types. In var number equals 101, number is inferred to be of type integer. Oh dear, my cats decided to go and hunt each other. It's gonna be interesting. If enable null safety, variables can't contain null unless you say they can. You can make a variable nullable by putting a question mark at the end of its type. For example, a variable of type integer question mark might be an integer or it might be null. If you know that an expression never evaluates null, but Dart disagrees, you can add exclamation mark to assert that it is null and to throw an exception if it is. An example is integer x is nullable but not null, and exclamation mark. Okay, so similar concept to C#, JavaScript, and several other languages. Very, very, very familiar. Okay, I like it. When you want to explicitly say what any type is allowed, if you want to explicitly say that any type is allowed, use the type object question mark. Okay, so that means that it can be, because object, absolutely everything inherits from object except the null, because let's assume that we have the null safety enabled, because who wouldn't, right? So that covers both null and everything else. Or just object if you didn't. Okay. Okay. If you must defer type checking until runtime, special type dynamic exists. Okay. Dart supports generic types like list integer, a list of integers or list object, list object of a type. I wonder how far the generics go if you can do like extra clauses of this and that, whatnot. Curious about that. I like strong, extensive generics, but I don't have big expectations. As long as it's a little bit more extensive than Go, I'll be happy. Dart supports top-level functions such as main, as well as functions tied to a class or object, static and instance methods, respectively. You can also create functions within functions, nested or local functions. Okay. Similarly, Dart supports top-level variables, as well as variables tied to a class or object, like static and instance variables. Instance variables are sometimes known as fields or properties. Yep, I call them fields. Yeah. Unlike Java, Dart doesn't have the keyword public, protected, and private. If an identifier starts with an underscore, it's private to its library. Okay, so we have similar to what, for example, TypeScript, I think, was trying to do, or to some extent. Okay, I like that. I like that concept. It's familiar. Tara says Dart is 3.8 now, starting from 2.0. Sound null safety is not optional. Okay, that's awesome to hear. Sound null safety is always awesome. Okay. Identifiers can start with a letter or underscore, followed by any combination of those characters plus digits. Dart has both expressions, which have runtime values, and statements, which don't. For example, the conditional expression, condition question mark expression 2 has a value of expression 1 or expression 2. Compare that to if-else statement, which has no value. A statement often contains one or more expressions, but an expression can't directly contain a statement. Okay, makes sense. Dart tools can report two kinds of problems: warnings and errors. Warnings are just indications that your code might not work, but they don't prevent your program from executing. Errors can be either compile time or runtime. A compile time error prevents the code from executing at all. A runtime error results in an exception being raised while the code executes. Okay, then we have additional resources like the core library documentation, Dart API reference, and we have even Dart style guide. Look at that. Okay, so that was the overall overview, which is a very nice first impression, I must say. Yes, this page was helpful. Awesome. So let's learn a little bit more about variables. Let's dive deeper. Okay, we've got something here. So here's an example of creating a variable and initializing it. The variable name is Bob. Variables store references. The variable called name contains a reference to a string object with a value of Bob. The type of the name variable is inferred to be string, but you can change that type by specifying it. If an object isn't restricted to a single type, specify the object type or dynamic if necessary. Okay, so looks like we probably won't have like union types. Too bad. Object name Bob. Okay, could be anything else. So because this is an object, right? And it's not like final. If we're gonna do object name Bob, right? We can just do print name. Okay. Then we can do name is not Bob, right? And we can still do print name. Then we can do name is 11, and print name, and it should be fine because a number is an object. So it should be absolutely fine. Yep, there we go. Okay, so I guess print just takes an object, or print probably has more shenanigans and they just take dynamic or something. Another option is to explicitly declare the type that would be inferred. Okay, there we go. Note, this page follows the style guide recommendation of using var rather than type annotations for local variables. Okay. Yep. I mean, personally, for example, in C# you have the same thing. You use literally the same, right? Type blah blah, and you can easily do var, right? In this case, it will break it because it will assume that it's a string, so it's gonna work, right? So you can use exactly the same. So most of the time, whenever it's actually really obvious what you're assigning, like, you're not dealing with numbers that could be, you might be meaning float or double, like those weird situations, or you're not dealing with some other weird cases. When it's really obvious what you're assigning to in here, var, in my opinion, is preferable because it makes it easy to read your code because you're not focusing really on what is the type of this thing. You already kind of have it in the back of your head. Most often, you're actually assigning just, let's say you have a function of that, whatever. Take something like process payment, right? And as input, you're getting some maybe payment info, right? And you're doing something here. So it's often that you just want to do var, let's say that you want to extract a few things that maybe are slightly processed. Maybe the I know, bank info, right? Will be simply info of the payment dot bank dot something, right? You don't want to keep writing that every time, and you don't really care what is this type in here named, so you don't need to have whatever somebody named that. Oh, this is the bank details DTO or something, right? You start reading that and it's like clutter. You don't care. You know that your var, this is statically typed, so you can do bank info dot and you continue typing. You know it's safe. And just in case somebody does some kind of refactoring where they, I don't know, change the name of the type, they don't ever need to come in here and change the name of a type here within this function. They don't need to touch it. So whenever it's clear what this type is, or irrelevant, as long as it's, you can be sure that there's no weird situations like, with numbers, var is great. But again, that's one of the personal opinions. Looks like the style guide recommendation is to use var. At least for local variables, of course, because you don't want that in those more formal situations like arguments of a function or return types, or possibly, I don't know if it's even possible for classes and whatnot. So yeah. Comments, nobody's saying anything. All right, let's continue. So, okay, these are all simple things. Let's go a little bit deeper into null safety. The Dart language enforces sound null safety. Null safety prevents an error that results from unintentional access of variables set to null. The error is called a null dereference error. A null dereference error occurs when you access a property or call method on an expression that evaluates to null. An exception to this rule is when null supports the property or method like toString or hash code, With null safety, the Dart compiler detects these potential errors at compile time. There we go. For example, say you want to find the absolute value of an integer variable, I. If I is null, calling I.ab absolute causes a null dereference error. In other languages, trying this could lead to runtime error, but Dart compiler prohibits these actions. Therefore, Dart apps can't cause runtime errors. Let's not say that. Let's just say that it's harder to do that. Null safety introduces 3 key changes. When you specify a type for a variable, parameter, or another relevant component, you can control whether the type allows null. To enable nullability, you add a question mark to the end of type declaration. There we go. So this one's nullable, this one is not nullable, or non-nullable. Okay, you must initialize variables before using them. Nullable variables default to null, so they are initialized by default. Dart doesn't set initial values to non-nullable types. It forces you to set an initial value. Dart doesn't allow you to observe an uninitialized variable. This prevents you from accessing properties or calling methods where the receiver's type can be null, but null doesn't support the method or property used. Yep, that makes sense. I remember, throughout the years in C#, slowly and slowly, all those features were being added, the way of, adding nullability, enforcing it more, and whatnot. So, yeah, this all sounds very, very familiar. And you can't access properties or call methods on an expression with a nullable type. The same exception applies where it's a property or method that null supports, like hashcode or toString. Some null safety changes potential runtime errors and edit time analysis errors. Null safety flags a non-null variable when it has been either not initialized with a non-null value or assigned a null value. This check allows you to fix these errors before deploy your app. Yep. Makes sense. Okay, so this makes me happy that it is enabled by default. This is awesome. Default value. Uninitialized variables that have a nullable type have an initial value of null. Even variables with numeric types are initially null because numbers, like everything else in Dart, are objects. Okay, so integer can be nullable, line count. You can assert that line count is null. There we go. Production code ignores the assert call. During development, on the other hand, assert condition throws an exception if condition is false. For details, check out assert. Yep, makes sense. These are all the extra things you can add in your debugging code just to make sure that nothing weird happens. But yeah. With null safety, you must initialize the values of non-nullable variables before you use them. Yeah, follow question mark, it won't work. Very, very simple. We're gonna do this. It's gonna work. Right? It's all happy. Let's just get rid of this part. If I'm gonna remove this, this is probably gonna assign default value of 0. Oh, no. No, must be assigned. It's interesting that I'm not getting an error. Normally those show up here. Oh, now it showed up. Okay. So it just didn't trigger initially. Yeah, it must be assigned. Okay, so it doesn't even give a 0 value because integers are objects. Therefore, there are null by default, and null is not allowed here. Now it's gonna be fine. A question mark, right? It's just null. Okay, I like that it doesn't default to 0. It kind of is nice because I never like this assumption of, oh, it's going to be 0 or it's going to be true or false. You don't have to initialize a local variable where it's declared, but you do need to assign it a value before it's used. For example, the following code is valid because Dart can detect that line count is not null by the time it's passed to print. So end line count. If we like to count, set this to that, otherwise set this to that, right? And by the time we're using it, in both execution possibilities, it was set. So that's great. So this is awesome. Awesome, awesome, awesome. Top level and class variables are lazily initialized. The initialization code runs the first time the variable is used. Oh, okay. So top level and class variables. All right. Huh. I need to try that. I really need to try that. So let's say that I'm going to say top level and class variables. So let's for now say final top level value is, I don't know, calculate value, right? This is gonna be it. And we're gonna straight up do gonna return just a integer, calculate value, which will be simply print calculating value now, after which we return, I don't know, 42, okay? And let's just make it integer. There we go. So I can do something like print, hi there, and then we're gonna do print the value is top level value. So if what they said is true, that means that we'll see hi there, then we're gonna see calculating value now, and then we're gonna see the value is run. Ha! It actually worked that way. Oh, this is interesting. So that means that, you know, you can't rely on this top level code here to actually be, oh, I'm gonna declare this and then that and then that. And by the time I'm doing this here, I'm assuming that all this already happened in order. No, it's not, because it's top level. It's not within any function, right? It's not due to be executed, right? It's just a declaration of it. And therefore, because it's a declaration, it will be nice because you can say, hey, I know final config is, get config, right? And maybe before that, you were doing something like final something is something where you pass config. Probably wouldn't work, but maybe. I don't know. I'm just thinking that, it kind of resolves itself because one calls the other and therefore it will evaluate each other in correct order without you having to do work. So yeah, that's fun. That's nice that they pointed it out. It's not the obvious thing. So yeah, this is kind of cool. I wonder how often it's gonna come in handy. So now let's look at late variables. What the hell is late variables? The late modifier has two use cases. Declaring a non-nullable variable that's initialized after its declaration, and lazily initializing a variable. Wait, so declaring a non-nullable variable, Okay, that's initialized after its declaration. I mean, we already saw that, so maybe that's just explicitly. And the other one is lazily initializing a variable. So often Dart's control flow analysis can detect when a non-nullable variable is set to a non-null variable before it's used. But sometimes analysis fails. Two common use cases are top-level variables and instance variables. Dart often can't determine whether they are set, so it just doesn't try. If you are sure that a variable is set before it is used, but Dart disagrees, you can fix the error by marking the variable as late. Okay, so in this case, late string description, because here is normally as a top level, it's not set anywhere, right? So when you're, okay, I see. So let's again plop it here. So without late, right? The compiler just sees, okay, we defined string description, but it's not defined anywhere, right? It doesn't really go in depth that, oh, maybe it's set somewhere within a main function and it's gonna go in there. It's out of context of this top level thing, right? So we can just say, hey, it's late, so I am 100% sure that it is done, right? So it's gonna run. But that opens me probably to a mistake where I can do this and run it and have runtime error because I said it's set, but it wasn't. So, hey, the error is on me. Okay. If you fail to initialize the late variable, a runtime error occurs when the variable is used. There you go. When you mark a variable as late but initialize it at its declaration, then the initializer runs the first time the variable is used. This lazy initialization is handy in a couple of cases. The variable might not be needed, and initializing it is costly. You're initializing an instance variable, and its initializer needs access to this. Okay, so I guess this will be nice for local variables. So where we have a local variable and you have maybe if this do that, if this do that, you kind of need it in both cases, but not, you don't want to have it somewhere in there. And you're initializing an instance variable, so on a class, right? And its initializer needs access to this. Oh, so basically we need the whole object to be created first before we can fully initialize it. Okay. So in the following example, if the temperature variable is never used, then the expensive read thermometer function is never called. So this is a program's only call to read thermometer. Late string temperature is read thermometer, right? Because this maybe never was actually used because of a statement. It never executed, right? So I want to try it inside a function, like a simple one. Let's say that I have let's say that I have something relatively simple. Maybe I don't know. Late name is late string name. Okay. So we define a variable name, right? And now it's yellow because we haven't used it anywhere. So the thing is that we have if statement. If something, and then if else something, and then at the end else, right? And this editor is so tiny, but we can't make it like full screen, can we? No. I'm gonna zoom out a little bit so it's a little bit easier for me to code in it. I hope it's large enough. And Taras says, I use late a lot for initialization. Yes, that sounds like perfect thing for initialization. So let's say an if we have, something like if I don't know, let's say that we have user input, right, is Ben, right? So maybe if user input is Ben, right? We're doing something where OMG, get out. We just do print, right? And we just do, normally it'll be exit program, or we'll just do return, right? We don't even need to attach the thing here. Otherwise, if else, maybe user input, I don't know, is shorter than something and something, right? Maybe it's shorter than this. We want to do name is the user input, right? Otherwise, we're gonna do that the input maybe is trimmed, the name is whatever, trim the user input. And add ellipses at the end, right? I'm of course not doing it correctly here, but I don't know if this works here. If user input dot length, do we have something like that? Looks like we have is less than 10 characters, right? We can do something. And yeah. And then at the end, we can just say that, hey, print name. And just like that, we, in theory, have a situation where we define this only once. Therefore, we define this, therefore we can do something with it after this whole if statement thing. But we had a situation where maybe we didn't have to initialize it because the name was maybe more of get input or something, or who knows, something. Bunch of options. I mean, this is sure, whatever. I can see a million ways that this could actually be useful. All right, let's move on. So final and const. If you never intend to change a variable, use final or const. Either instead of var or in addition to a type. A final variable can be set only once. A const variable is compile time constant. Const variables are implicitly final. So instance variables can be final but not const. Okay. So here's an example of creating and setting a final variable. So file name Bob. So in this case, it's implied that it's a string, and we can't change it afterwards, right? The same thing here. It's literally the same thing. You can't change the value of final variable. Yep. Use const for variables that you want to be compile time constants. If a const variable is at the class level, mark it a static const. Okay, so we have context. We have a concept of static stuff. Okay. Where you declare the variable, set the value to a compile time constant such as number or string literal, a const variable, or the result of an arithmetic operation or constant numbers. Something simple. You can't call a function here as far as I know. So the const keyword isn't just for declaring constant variables. You can also use it to create constant values, as well as to declare constructors that create constant values. Any variable can have a constant value. Okay, so var foo is a constant this. Oh, okay. And this is constant that, and this is that. Oh. Because this is a const, this will be assumed to be const too. So I assume that this means that contents of this list can't change. So let's see if we can figure out how to deal with lists. Something simple. So let's say we do something like var names is Ben and not Ben. Okay? We've got two names. And we simply do print names. That should work, right? There we go. Print it out. Can I do names dot add maybe Ben, right? Run. Okay, that works. So if I'm gonna make it into a final, I assume that it will still work because we assigned this object which holds the values. Here we didn't change the object that's assigned to the variable. We just modified the content of the object, right? So this still runs. If I make it a const, this will be problematic, I assume. Yep. Because now this list, because it's const, that means nothing ever changes. It's always the same. So I assume it's the same as this. Run. Again, because we made it, hey, you can't change the contents of the list. But what if I have a list with a list inside? This doesn't work, but names. One. Add maybe Ben. Can I do that? Can I names one as to print? Will that work? Okay, so I was able to print that out. Okay, so if I'm going to const on this, I froze the entire thing. Huh. So that means that I didn't freeze just this outer one. Everything inside is frozen. It's constant. So it's not that I need to define this thing separately. I mean, looks like I can. But the moment I do this, it's implicitly that. Because suddenly, I can't do this. Huh. Okay. Good to know. Learned something not obvious. All right. So you can omit const from the initializing expression of a const declaration, like for bas above. For details, don't use const redundantly. You can change the reference of a non-final const you can change a reference of a non-final, non-const variable, even if it used to have a const value. Okay, so I can basically, yeah, so if I had this as a var, right? It was linking to a value that's const, but I can still say names is la, right? And this would be happy. Because I didn't change this object. I just replaced it completely. Yeah, this will be fine. uh, what? Oh, because I'm printing out just one element. There we go. So yeah, we just changed it. You can't change a value of a const variable. You can define constants that use type checks and casts is and as, collection if, and spread operators. So constant object I is 3. Where I is a constant object with an int value. Yep. Const list I as int. So in this case, I typecast it from object to int. Okay. Constant map. If I is an int, we just return int. Okay. All right. I like that. So we can check for those. And a set if list is list of ints, just spread to here. Okay. Although a final object cannot be modified, its fields can be changed. In comparison, a const object and its fields cannot be changed. They're immutable. For more information on using const to create constant values, see list maps and classes. Okay, I find this surprisingly easy, clear. We just check, even nest stuff gets, completely immutable the moment we put a label on the outside. So it looks like we can't have immutable object with something in it that's mutable. Maybe there's a way around it. Don't know at this point, but initially it looks like we can't. Once you mark it something mutable, it's immutable all the way down. That's good. And Tara says, you need to cast first to list. Const list aside list. Okay, so it looks like we can do something with casting. Okay. All right. All right. Possibly. I will look into that in the future. For now, I'll just move on because, again, that looks like an edge case that I shouldn't be worrying too much about until I actually hit a problem related to it. But it's just nice to know that there's a way to do things. Okay. So next thing is wildcard variables. Version note. Wildcard variables require a language version of at least 3.7. Ooh, so this is something relatively new. I'll be right back because my cat is about to eat the fiber cable. Alrighty, I'm back. That says when you had names one add, it failed due to casting, not because of const. Ah, so let me just get back to it. We had something of this, right? So this was the method add isn't defined on the type object. Oh, okay. So when I'm extracting, because I'm mixing strings and this. So I could probably do this as, what was it, list of string, I guess, add, run, a supported operation add. List, yeah, we define it like this. Like this, it should run, right? Yeah, this works. But at the moment we make it const, it's like, oh, sorry. The same thing if we're gonna do const, we're gonna get the same error, right? Yeah, so that makes the inside one const as well, no matter what. Okay, but thank you for pointing out the one with casting. It says now it failed for a correct reason. Nice, thanks. All right, wildcard variables. That sounds fun. Well, anything wildcard is fun. Wildcard variable with the name underscore declares a local variable or parameter that is non-binding, essentially a placeholder. Okay. The initializer, if there is one, is still executed, but the value isn't accessible. Multiple declarations named underscore can exist in the same namespace without a collision error. So it's basically voiding the whatever was supposed to be there. It's like, oh, we need to do this thing, we need to do something with the returned value. It's just voiding it. Top level declarations are members where library privacy might be affected, are not valid uses for wildcard variables. Declarations local to a block scope, such as the following examples, can declare a wildcard. So local variable declarations. Var, this is 1, and this is 2. Exactly. For loop variable declaration. So we iterate over the stuff in the list, we just don't care what we're iterating over. Catch clause parameters. Try, throw, whatever error is, we don't care whatever it is, we're just gonna print oops, right? And generate type and function type parameters. So we have a class type, we don't care what the type is, we just call the function, and whatever it is, we'll always return true, right? So we don't care what a subtype is. Okay, it's good to know that we can do that, right? And function parameters, we can just constructor with okay. List where we don't care, it's always true. Integer, we don't care about names because we won't use them anyway. Yep. And type definition of function, because it's just type definition, we don't really care about the names. Okay. Enable the lint and necessary underscores to identify where a single non-binding wildcard variable underscore can replace the previous convention of using multiple binding underscores to avoid name collisions. Oh. I guess before that, there were naming collisions for where you needed to do double underscore, triple underscore just to do those things. Okay, makes sense. Now they just don't act as the same variable. Okay, makes sense. All right, this is fun. Okay, let's go on operators. And soon we're going to start getting close to actually be able to do something with code. Fun. Okay, so operators. Dart supports the operators shown in the following table. The table shows Dart's operator associativity and operator precedence from highest to lowest, which are an approximation of Dart's operator relationships. You can implement many of these operators as class members. Okay. All right. So unary postfix. So plus plus, minus minus, something at the end of the expression, right? Ew, okay. All right. Prefix. Okay. Await. Can we override await? That's my question. Can we override function of a dot? Table shows Dart's operator associativity and operator precedence. Okay. Yeah. Okay. So let's leave it to the left. none, and whatnot. Okay. So we have basic multiplications. That's a strange multiplication. Uh, oh, that's just division, probably integer-like. This is like float division, integer division, I assume. Yeah, bit shifts and stuff. Bitwise and XOR or relational tests. All the basic stuff. Conditional expression. Cascade. Wait, what is cascade? Dot dot. From to, I presume. That's an interesting one. Then we got assignment. What's this one? Maybe these are binary or something? Oh, these are bitwise probably. Yep. And then we have spread operators. All right. Warning, the previous table should only be used as a helpful guide. The notion of operator precedence and associativity is an approximation of the truth found in the language grammar. You can find the authoritative behavior of Dart's operator relationships in the grammar defined in the Dart language specifications. Okay. Yeah, when you use operators to create expressions, there are some examples. Here are some examples. Yeah. So we use the postfix. We just add, assign, compare, ternary, whatever they call it, conditional, and is. They define is in here. Yeah, relational and type tests. So we have relational, and then we have as, is, and is exclamation mark. Is that okay? Operator precedence example. In the operator table, each operator has higher precedence than the operators in the rows that follow it. For example, the multiplicative operator, uh, or module or whatever, has higher precedence than and thus executes before the equality operator equals, which has the higher precedence than the logical AND operator. That precedence means that the following two lines of code execute the same way. Yeah, parentheses improve readability to some extent, right? Harder to read but equivalent, right? Because we know that, oh, this is going to execute first, right? This small thing. Then we're going to execute this. And at the end, we're going to execute this one. Yeah. For operators that take two operands, the leftmost operand determines which method is used. For example, if you have a vector object and a point object, then a vector plus a point uses vector addition. Okay, so good to know that whatever is on the left is the thing that matters. Alrighty. So going to arithmetic operators, we have add, subtract. Yeah. So this is divide, returning an integer result. Yep, just like I thought. And this is just reminder of the integer division. So with divide, if we do this, okay, so the normal division, even though we're starting with an integer, it will return a double. Okay. This is kind of, I guess that's just the operator, yeah. Okay. All right. So Dart also supports both prefix and postfix, increment and decrement operators. And that's where you sometimes might be careful with what executes first. For example, int A and B, A0, A is plus plus A increment before B gets its value. So let me see. After, right? Then we go before. And then assignment is all the way somewhere in the bottom. Yeah, exactly. So they will always execute before assignment. Mm-hmm. There we go. And after B gets its values. Oh wait, what? Oh, okay. All right, so this is increment before, this is increment after. B gets its value. Huh. Yep, that's where you need to be careful. That's why I don't like using those, because sure, you can do so much in one line, but it just, you know, unless you're actively thinking about it, it's just easier to make a mistake. Equality and relational operators. The following table lists the meanings of equality and relational operators. Nothing inventive here. It's all the same. To test whether two objects x and y represent the same thing, use equals equals operator. In the rare case where you need to know whether two objects are the exact same object, use the identical function instead. Here's how the double equals operator works. If x or y is null, return true if both are null, and false if only one is null. Yep. Return the result of invoking the double equals method on x with the argument y. That's right. Operators such as equals equals are methods that are invoked on the first operand. For details, see operators. Yep, makes sense. Here's an example of using this. All right, that's simple. Type test operators. As is and is exclamation mark. Operators are handy for checking types at runtime. So as is a typecast, also used to specify library prefixes. So the as, I assume, wonder what it does if the typecast fails. It returns null, or what the hell? Is true if the object has the specified type, and is exclamation mark true if the object doesn't have a specified type. Oh, so this means is not. I actually prefer how C# likes it. Does it where you can literally type is space not instead of the random exclamation mark. Because exclamation mark as a postfix, right? Usually used to like, hey, this must be this type, right? On types. And that's the only way you use it. As not, usually put it in front of something. So this is inconsistent. I don't like this. But this is nitpicking. The result of object is T is true if object implements the interface specified by T. For example, object is obj is object question mark is always true. The as operator to use the as operator to cast an object to a particular type. If and only if you are sure that the object is of that type. Okay. Example, employee as person, first name Bob. If you aren't sure that the object is of type T, then use is T to check the type before using the object. Okay, so basically the as isn't like in, for example, TypeScript, where you would have, where it returns undefined when the typecast fails, right? You need to actually have explicit if statement first, right? If employee is person, I guess it's already, it didn't typecast it for you to make it a person yet, but you can typecast it here, I guess, within it. The code isn't equivalent. If employee is null, or person, the first example throws an exception. If the second does, the second does nothing. Yeah. Third is saying is. Yeah. So let's say here I could do if names one is list of string, right? I could do something, or is not list of string, right? That exclamation mark. I don't like it because the only other place that I'm aware of is when you say, when compiler says, "Oh, you know what? You have something nullable, and you need to convince that, uh, let's say you need int. My value is some other object nullable int exclamation mark, right? Where you know that you already checked for it, and you put exclamation mark to tell it that it's not nullable. I know what I'm doing, right? And you get a proper integer, right? That's the only place where you use the exclamation mark, so it's not meaning not. The only not you're using it is where you negate a value, but then you would put it here, and that will negate this entire value. So in theory, this is supposed to be this. If you want it to be consistent. That's why I like this, which is possible in C#, is not list. Just a little thing. I kind of like that. Initially, it's like, oh my gosh, entire word, but as you're actually typing code, it's quite ergonomic. I like it personally. You end up reading the code, it's like, oh, this reads nice. Oh yeah, is not is equals to as. Not really. Is equals is not is definitely not as. Because as assumes is checks. All right, so we finished this one, right? Okay. Assignment operators. As you've already seen, you can assign values using the equals operator. To assign only if the assigned to variable is null, use the double question mark equals operator. Okay. To assign only if the assigned to variable is null. Oh yeah. Okay. So this is just like in JavaScript and C# again. Similar syntax. Assign a value, and this is assign a value to B if B is null. Otherwise, B stays the same. Yeah. This is assign it only if empty. So this would be often used, let's say, you were doing something with B where you were supposed to initialize it, but you maybe had a possibility that due to value not being in a config file or something, you might end up with this being just empty, right? So you can say this and some default value or something. And there you go, just in case at the end, you can make sure that you have some kind of value. Alrighty. So what's next? Compound assignment operators such as plus equals combine operation with assignment. Okay, and we have a lot of them, including bitwise and fancy division-wise. Or, and all the fun stuff. Okay, so it's all possible. Here's how compound assignment operators work. For an operator op, for example, this plus equals b is basically a equals a plus b. Yep, that makes sense. The following example uses assignment and compound assignment. operators. I mean, yeah, this is normal. Logical operators. You can invert or combine Boolean expressions using the logical operators. So exactly, we have not in front. That's what it means, not. Inverts the following expression, changes false to true and vice versa. I don't know why I did end. This is supposed to be a Boolean. But yeah, whatever. This is for Boolean stuff. And then we have logical or, logical and. Yep. This is basically most useful in your if statements and whatnot. Nothing crazy here. Looks like any other code. Bitwise and shift operators, stuff I really don't like. Sometimes comes in handy. So we have our AND or XOR. Yeah, it all looks just defaults. Okay. There we go. The behavior of bitwise operations with large or negative operands might differ between platforms. To learn more, check out bitwise operators platform differences. Oh yeah, because you can have x64, x64, or 64-bit systems, 32-bit systems. Maybe some of them might just deal differently with specific values. So yeah, just be careful of that. And this is all standard. I'm not going to go into that. Oh yeah, or JavaScript, which is entirely different set of weird behaviors. Okay. Conditional expressions. Dart has two operators that let you concisely evaluate expressions that might otherwise require if-else statements. So we have standard ternary expression, right? If condition is true, right? Evaluates expression 1, otherwise evaluates and returns expression 2. That's standard. And then we have this one. If expression 1 is not null, returns its value, otherwise evaluates and returns the value of expression 2. So again, the same as JavaScript or C#. Same stuff. When you need to assign a value based on a Boolean expression, consider using the conditional operator. So var visibility is public, if yes, public, if not, private, right? If the Boolean expression tests for null, consider using the if null operator instead. Yep, also known as the null coalescing operator. There we go. So you have this. And in JavaScript, often, even though JavaScript nowadays has no null coalescing operator, people are still using just or, because you can do that. But here in more type-safe environment, just use null coalescing. Yep, makes sense. So the previous example could have been written at least 2 other ways, but not as succinctly. Slightly longer version uses the ternary operator, right? Name is null, right? For checking if it's null, then name, otherwise not. Well, this is way easier because you don't have to repeat this name thing and check for null. It's all within 2 question marks. Of course, you can decipher it. A very long version uses if-else statement. Yep, string is this, then that, and we needed to convert this into an entire function. So next, cascade notation. Okay, so now we're going to learn about a cascade. The cascades, dot dot and question mark dot dot, allow you to make a sequence of operations on the same object. In addition to accessing instance members, you can also call instance methods on that same object. This often saves you the step of creating a temporary variable and allows you to write more fluid code. So consider the following code. For our paint, right? So we created a paint. So then the color is colors black. So I guess we do paint.color color is, we set it to black. Paint stroke cap is brown. Paint stroke width is this. Okay. The constructor paint returns a paint object. The code that follows the cascade notation operates on this object, ignoring any values that might be returned. The previous example is equivalent to this code. Okay, I see. All right. Okay. So, okay. I can see. Hmm. Okay, I kind of like it. I kind of like it. I don't like that this suggests that you're supposed to format it this with that and deal with formatting. But at the same time, you don't have to read that and have all this clutter. Okay, I like that. This reminds me a little bit of what you can do in C sharp, because in C sharp, in theory, you could, like here you can just have this, right? That's great. But in C sharp, you could just do this and just do this, I believe, where this already initializes your paint, and then you just correct your, assign or change some extra values, right? So both are nice. I kind of like the two dots because it's a different syntax, and I guess I have affinity for different things. So yeah, it's fun. Okay. So if the object that the cascade operates on can be null, then a null shorting cascade. For then use a null shorting cascade for the first operation, starting with question mark dot dot guarantees that none of the cascade operations are attempted on that null object. Oh, that's nice. Okay, so we can say that, oh, just in case. Wait, guarantees that none of the cascade operations are attempted on that null object. Oh, so that's in case the entire document was supposed to be null. Okay, because this already could have returned a null. Okay, so this is a little bit more powerful than this thing, because this assumes that it's gonna always create an object. Well, this might be where you have entirely. Oh, so you do. Wait, you don't even save the object. You just get an object from somewhere. You totally don't save it, and you can still call a few things on it. Okay, I see. So that's quite more powerful. I'm starting to like it. Yep, this is fun. Definitely fun. And therefore, okay, just in case we have it, let's do that. And do a few other things. But wait a moment. If the object that the cascade operates on can be null, then use null shorting cascade. Well, then this makes no sense. Because here we're suggesting that the whatever, because we called query selector, confirm, right? We got an object. But we're suggesting that, oh, we might not have got an object. Therefore, if we haven't got an object, we're not gonna call this. But if we got an object, we're gonna do text content. But in the following ones, we're just ignoring the fact that we might have a null. So, what? So this is equivalent of the following: final button, right? Button. Oh, we just do for the first one. Oh, I see. Use for the first operation. Okay, that makes sense. All right. Okay. I'm just bad at reading entire thing. Okay. All right. That's awesome. That's super awesome. I really like that we don't even need to save the whole thing. This is like considered one little unit. What happens if I have some random expressions in the middle that wants to recalculate something? Can also nest cascades. For example, address book is starts here. We have this, that, that. Bam, bam, bam. We close this one. Dot build. Address book builder. We got an object from the builder, right? And we do name is Jenny, email is this, phone is, and then we have phone builder and another separate context of parentheses, right? Or scope or whatever. Okay, so parentheses can be used to kind of create those separate little scopes. Okay, that's doable. So this scope ended, right? And on this entire phone, we called build to complete the phone builder, right? And then as we complete the entire book builder, we finish building this. Okay. Somebody could make it smarter and make it where when you call build, if you didn't finish building something, it's gonna build it automatically. But whatever. Love it. Be careful to construct your cascade on a function that returns an actual object. For example, the following code fails. String buffer, right? SB. Write foo. Dot write bar error. Method write isn't defined for void. Void, yeah, because this doesn't return anything. Yeah. So in this case, you should do that's an interesting, because if we create a variable SB, can we just do dot dot write and dot dot write? Does it require some extra imports for it to work? Can I just do this? And then just do something like SB dot write all clear to string, right? So be final text is this print text. But this isn't happy because it expected an identifier, right? So no, I will need to do SB. Nope. Huh. I'm surprised. I mean, it would work if I would have done this, right? Then it would be like, oh, string builder, string builder. Oh, I mean, string buffer, sorry. Expected an identifier. Oh, wait. Why does it say expecting identifier? Go figure. Don't know. But I guess it doesn't work here. Strictly speaking, the double dot notation for cascades isn't an operator. It's just part of the Dart syntax. Okay. Makes sense. Something tells me there are some quirks with how it works, like they mentioned here, and what actually where we can trigger and where we cannot. Because look at that. Here we did var paint. We assigned it to a variable, right? And we were able to do this. And here isn't defined for void. So it suggests that we can execute functions on it. Because everywhere else is just assignments. Var SB is this, right? SB dot write EA. So in theory, this should work, right? Run. Yes, EA. But these don't work. They don't see the SB at all. Expected an identifier. SB dot. It's not empty runtime clear write. No such method. Yeah. Don't know. They don't see because I have the semicolon. It's saying that I need to not all. I shouldn't include the semicolon. Ah. That's a little detail that I haven't noticed. Oh, that's how we define how the entire block works. Oh, okay. Oh, that's simple. All right. Totally didn't notice that they don't have semicolons. There we go. Now it works. Okay. So it's possible. We can still have the variable. We can still do the bunch of weird stuff. Hey, can we do it like this? Oh, yeah, we can. Oh, this is fun. This opens the doors for weird formatting. This is awesome. Okay, so we have this thing, and yep. So in theory, I could do print, right? I do string buffer, right? To string, right? And this should run. There you go. They just want you. They just way you can't mix single dot and double dot without triple dot or parentheses, probably. Yeah, they just say you can't mix them. Yeah. And yeah, of course that. Yeah. Okay, this is fun. I like that because suddenly you don't have to worry about returning the thing every time. So you don't need to make those return stuff. Awesome. I really, really, really like that feature. That makes me happy. So yeah. Spread operators. Spread operators evaluate an expression that yields a collection, unpacks the resulting values, and inserts them into another collection. The spread operator isn't actually an operator expression. The dot 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 slash dot 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 question mark syntax is part of the collection literal itself. So we can learn more about spread operators in the collections page. And Tara says, it's so fun to learn Dart with you. You're not learning much, I'm afraid. If you are, then I'm very happy about it. But, yep. I know that often it's different to use the language and technology than actually look at learning material. And it's like, oh, I never thought of this simplest edge case. Like, never encountered it. Or just get a refresher. That's another thing. Like, I'm really due for a proper C# refresher to get up to date, like properly from the beginning to the end, everything, how it ties in nicely. Okay, spread operators. We went to that. Okay. Because it is an operator, the syntax doesn't have any operator precedence. Effectively, it has the lowest precedence. Any kind of expression is valid as a spread target, such as a plus b. Okay, so a plus b will be evaluated, and then you get the spread. Oh, okay, good to know. So, oh, that's all we get about that. I guess we'll learn more about it in collections. So other operators. Whoa, it's nearly 1 a.m. So I guess I'll finish this and comments, and I'll be wrapping up for tonight. Wow, this will be at least 2 more live streams probably to go through all of this. So other operators. You've seen most of the remaining operators in other examples. A function application represents a function call. Subscript access represents a call to the overridable square brackets operator. Example, foo list square brackets 1 passes the integer 1 to full list to access the element index 1. This one, conditional subscript access, like square brackets, but the leftmost operand can be null. Example, bam, with a question mark. Passes the int 1 to full list to access the element index 1 unless full list is null, in which case the expression evaluates null. Okay, this is nice. Just, you don't need to create separate check first and then do stuff, just all in one line. Nice. Member class. Member access refers to a property of an expression. Example, foo bar selects property bar from expression foo. Conditional member access, just like the normal dot, just, evaluate to null in case the left operand is null. An exclamation mark, not null assertion operator, casts an expression to its underlying non-nullable type, throwing a runtime expression if the cast fails. For example, foo exclamation dot bar asserts foo is not null and selects the property bar unless foo is null, in which case runtime exception is thrown. Exactly. And for more information about the dot and other operators, see classes. Ooh. This about classes? I guess, yeah, because you can design stuff to just be nice and maybe create your own variants of those. That'll be fun. Okay, so last section for tonight. The comments. Task says, there are a couple of interesting things. Also, it is interesting to see how you consume introduction. Yes. I can see that being interesting. All right. Comments. Dart supports single line comments, multi-line comments, documentation comments. Okay, this is gonna be super quick. Single line comments. A single line comment begins with double slash. Everything between double slash and the end is ignored by that compiler. There you go. Looks standard. Multi-line comments. A multi-line comment begin with slash asterisk and ends with asterisk slash. Everything between them is ignored unless a comment is a documentation comment. Yep. And they can nest, of course. Okay. Documentation comments. Documentation comments are multi-line or single-line comments that begin with triple slash, slash, star, star, or, yeah. This triple slash or consecutive lines has the same effect as a multi-line doc comment. Inside the documentation comments, the analyzer ignores all text unless it is enclosed in brackets. Using brackets, you can refer to classes, methods, fields, top-level variables, functions, and parameters. The names in brackets are resolved in the lexical scope of the documented program element. Okay. Here is an example of documentation comments with references to other classes and arguments. Okay, we have class llama. A domesticated South American camelid. Uh, Modern cultures, blah. So we have basically a bunch of text, a bunch of description, right? Bunch of description. And don't forget to feed them some food. So this will refer to feed. There you go. And food, which is this. And that, I guess, refers to some external something. So then this feeds llama food. And food is the argument in this case, not the type, right? The typical llama eats 1 bale of hay per week. Exercises, yeah, the exercise. Exercise the llama with an activity for time limit minutes. Okay. In the class's generated documentation, feed becomes a link to the docs for the feed method, and food becomes a link to the docs for the food class. To parse Dart code and generate HTML documentation, you can use Dart's documentation generation tool, Dart Doc. For an example of generate documentation, see Dart API documentation. For advice on how to structure your documents, your comments, see effective Dart documentation. Okay, I wonder how good the documentation is. An example would be nice because I'm often being disappointed by those. I don't know why. It's just this is the one thing that's surprisingly often made pretty bad. Okay, I'm gonna take a quick look at built-in types. I just can't stop just like that. I just need to see what there is. Oh no, there's a lot. Okay, this is the last one tonight. Alrighty. So built-in types. The Dart language has special support for the following. Numbers. So we have only int and double. So we don't have just single float, right? That's interesting. We don't have anything other than int. We don't differentiate between, different ones. That's scary. Strings. Only one type of string. Look at that. How nice. Booleans, records, which are, I guess otherwise tuples. Functions, lists, also known as arrays, sets, maps, runes, often replaced by the characters API. Oh, okay. So I guess runes are the basic and characters API is kind of an upgrade as in separate library. Just let my cat out. Be right back. Alrighty, I'm back. And then we've got symbols, which don't know what to think about it. Very generic word. And the value no. Alrighty. So this support includes the ability to create objects using literals. For example, this is a string literal, and true is a Boolean literal. Okay, because every variable in Dart refers to an object, an instance of a class, you can usually use constructors to initialize variables. Some of the built-in types have their own constructors. For example, you can use the map constructor to create a map. Some other types also have special roles in Dart language. Object, the superclass of all Dart classes except the null. Okay. Enum, the superclass of all enums. But I guess all enums extend objects. Feature and stream, used in asynchronous programming. Iterable, used for in loops. And in synchronous, and synchronous generator functions. Okay, so synchronous generator functions return iterable. Asynchronous ones return stream. Okay. never indicates that an expression can never successfully finish evaluating. Most often used for functions that always throw an exception. Okay, all right. Dynamic indicates that you want to disable static checking. Usually you should use object or object question mark instead. And void indicates that the value is never used, often used as return type. And the object, null, and never classes have special roles in the class hierarchy. Learn about these roles in understanding null safety. Then we've got numbers. Our numbers come in two flavors. So we have int, integer values no larger than 64 bits, depending on the platform. On native platforms, values can be from, standard 64-bit. On the web, integer values are represented as JavaScript numbers, as 64-bit floating point numbers with no fractional part. Yeah. And then we've got double. 64-bit double precision floating point numbers as specified by the standard. Okay. All right, I guess you're always stuck with large numbers. Okay. I guess you need to use external libraries to deal with more efficient solutions. Let's say you need an array of a lot of smaller numbers, right? And you don't need to waste so much data. Yeah. Oh well. Both integer and double are subtypes of number. The number type includes basic operators such as plus, minus, divide, and multiply, and is also where you'll find all the absolute, ceiling, and floor, among other methods. Bitwise operators such as this and that are defined in the int class. If num and its subtypes don't have what you're looking for, the Dart math library might. Integers are numbers without decimal point. Here are some examples of defining integer literals. Okay, so we have hexadex as well. If a number includes a decimal, it is a double. Here are some examples. There you go. And then we go later into gonna also declare a variable as a number, as a num. If you do this, the variable can have both integer and double values. Okay. Okay. All right. Integer literals are automatically converted into doubles when necessary. Okay. Equivalent to double. Here's how you turn a string into a number, or vice versa. There we go. So we take our integer, and it has a static function, static method, parse. Give it a string. There we go. String to a double, so we do double parse this. There we go. Integer string, so we do to string. And here to string as fixed, and we do 2 decimal places. There you go. The int type specifies the traditional bitwise shift, complement, XOR, and whatnot. More example. We go in bitwise. I'm not going there, hell no. Number literals are compile time constants. Many arithmetic expressions are also compile time constants as long as their operands are compile time constants that evaluate to numbers. Oh dear. Yeah, just simple number arithmetic is fine as constants. For more information, see numbers in Dart. You can use one or more underscores as digit separators to make them more legible. Multiple digit separators allow for higher level grouping. Sure. And then version mode. Note, using digit separators requires a language version of at least 3.6. Look at that. Strings. A Dart string object holds a sequence of UTF-16 code units. You can use either single or double quotes to create a string. Okay. Doesn't matter, single, double. Okay. You can put the value of an expression inside a string by using this thing. If the expression is an identifier, you can skip the curly brackets. To get a string corresponding to an object, Dart calls the objects to string method. Okay, so it automatically calls to string for you. All right. String interpolation. Yep, we just got normal value straight out of that. And here we have something more complex. Yep. Add equals operator tests whether two objects are equivalent, two strings are equivalent if they contain the same sequence of code units. You can concatenate strings using adjacent string literals and the plus operator. Standard. To create a multi-line string, use a triple quote with either single or double quotation marks. Single ones, double. Question. Wonder if this actually embeds the extra spaces and whatnot. I want to test that. So we have S1 and S2. So let's do multi-line string. We copy this and paste it here, right? And then we'll do print. Then we do S1 equals S2 equal, otherwise not equal. Now let's run it. And we'll say not equal. Okay, so this new character, new line character got in here and in here. Let me see if the last one is the same. Oh, look at that. The first one gets ignored, but the last one isn't. Ah. The first one gets special treatment. Okay, good to know. But that means that if I'm going to, let's say, do this, they're not equal. These in front all get counted. Okay. Too bad. You can create a raw string by prefixing it with R. Okay. So we ignore, all those backslashes. See rules and grapheme clusters for details on how to express Unicode characters in a string. Tara says, see you. All right. See you around. Was good having you around. Okay, wow, I'm already halfway through this whole thing. String literals are compile time constants as long as an interpolated expression is a compile time constant that evaluates to null or numeric string or boolean value. Oof. Okay, so we basically can treat strings as constants. That's great. That's good to see. Some languages don't have that. And these do not work in a constant string. Oh, as in we can't inject them? Wait a moment. These work in a constant string. Oh, as in here. Okay. Can't inject them into this builder. So something like just a number, this or other string works. But variables, right, won't work. Or throwing an entire list won't work either. Okay. Sure. I guess linked lists are not liked. Okay. So let's move on to booleans. We haven't heard much about those. To represent boolean values, Dart has a type named bool. Only two objects have type bool. The boolean literals, true and false, which are both compile time constants. Dar's type safety means that you can't use code like if, non-boolean value, or assert non-boolean value. Instead, explicitly check for values like this. Great. So we need to basically, check for null, check for none, all those things. We need to check explicitly. Mm-hmm. We can't just check if it's true or not because it's not a boolean. Okay, so now we go on to runes and graphemes clusters. In Dart, runes expose the Unicode code points of a string. You can use the characters package to view or manipulate user-perceived characters, also known as Unicode extended grapheme clusters. Unicode defines a unique numeric values for each letter, digit, and symbol used in all the world's writing systems. Because a Dart string is a sequence of UTF-16 code units, expressing Unicode code points within a string requires special syntax. The usual way to express a Unicode code point is \u and 4 characters, where the 4 characters is a 4-digit hexadecimal value. For example, the hard character is the specific number. To specify more or less than 4 hex digits, place the value in curly brackets. For example, the laughing emoji is 5 numbers. There you go. If you need to read or write individual Unicode characters, use the characters getter defined on string by the characters package. The return characters object is the string as a sequence of grapheme clusters. Here's an example of using the characters. So you import a package, right? And we have the hi and we have some, I guess, Cyrillic. Hi, right? The end of the string. Hi substring is title length -1. So it would just show some unknown character, right? The last character is hi.characters, the last. That changes it, right? That's nice. So it looks like this dot characters is like some kind of extension method that gets tacked onto the extension property that gets tacked onto the string, which is kind of fun. I like that. C# is getting extension properties, which is exciting. The output, depending on their environment, looks something like this. Yeah. For details on using the characters package to manipulate strings, see the example and API reference for the characters package. Lastly, we have symbols. A symbol object represents an operator or identifier declared in a Dart program. Okay, represent an operator or identifier. You might never need to use symbols, but they're invaluable for APIs that refer to identifiers by name, because minification changes identifier names, but not identifier symbols. Get a symbol of an identifier, use the symbol literal, which is just hash symbol, whatever, pound they call it, followed by the identifier, radix, bar. Symbol literals are compile time constants. Okay. There we go. So next time we're going to resume from records. And so far this is exciting. This is like a interesting combination of C# with a little bit of JavaScript with I don't know, it looks like a lighter version of C# with less of the old features, more of the new features. So very pleasant. Yeah, I guess that'll be it for tonight. I learned a lot. I actually got excited about language, which which makes me very happy. I'm looking forward to seeing how it works in practice, and the few areas where I'm interested and where I'm very interested about this is how difficult it is to write a backend server using Dart, like integrate with actual few things that I usually integrate with. Uh, let's say SerialDB. I don't think there is SDK for SerialDB, so that would mean writing some more complex code, but it could be fun. For sure, easier than in NIM. uh, so that's one thing. Another thing is how difficult it is to write like a web app. Let's say a web app that uses material design, Flutter, right? Wonder how that would work as something decent looking. How how would that compare to, let's say, using Quasar framework with VJS, which I know that is pretty easy to use, and I'm efficient with it. And then last question is how easy it is to suddenly move this code into mobile, to have a mobile application. Because if that's really all effortless, that'll be amazing, because hey, this language doesn't seem to suck so far. So yeah, we'll see. But that's it for tonight. So thank you for watching. I hope you learned something. I know I learned a lot. And see you probably next week. Yeah, maybe Monday, Tuesday, something of that sort. See you. Thank you again, and see you around.